Okay, Vishal, go back to you. Obviously, Mareana's very much been an innovator in AI, big data, really for over a decade. So, we'd love to hear what you're thinking and what you guys are seeing on that front.
Actually, even when Denise was describing, her HSML, right? I was thinking we are doing something similar in knowledge graphs. We just call it knowledge graphs, right? So essentially, at this particular stage, everything from a process manufacturing perspective, every step that people do, all the data that gets generated in that particular step, we are basically taking that transactional information and creating knowledge graphs. These are extensive graphs that represent what you actually do. And that, to your point, Denise, it completely unlocks the potential of people understanding what's happening on the ground. And then once you have a very good understanding of what's happening on the ground, then it makes a little bit more to start predicting what's going to happen tomorrow, right? And so this is real. I mean, we are doing it with slightly different technologies, but essentially the approach is very similar. And the way this is manifesting on the ground is, in some cases, it is becoming an aid for an operator on the shop floor. In some cases, the operator is no longer necessary, right? And in some cases, it can basically become, let's say, a digital assistant, right? So I'll give you one example. So in a fill finish line, multiple liquids coming together, getting into the vial, that's the vaccine that will go into the patient. If the concentration level of the key ingredient drops below a particular, let's say, threshold, then that is no longer usable. You have to throw it away. Historically, when something like that happened, everything that was manufactured for the last hour, 2 hours, because it takes that long for them to basically bring the system back to stable conditions, you have to throw it away. Now, with these models that we have, we can basically deploy it. As soon as it senses that it is coming below, it starts taking the remedial actions across the multiple different, let's say, pressure pumps, changes their settings so that it again goes back to the right threshold, right? So now, even if there is an occurrence, it will be happening, let's say, within, let's say, a couple of seconds till it corrects itself back. So the amount of, let's say, wastage that was created is no longer there. The amount of time you had to basically spend in terms of training the right people to be able to read the gauges, get very comfortable with that production line to do that set, is no longer there. So that kind of transformation from an IoT perspective is already happening. I already mentioned the bioreactor, right? So in the bioreactor, it's a complex 14-day process where living organisms are actually creating the right, let's say, things that go into the vaccines and whatnot, right? It's very difficult to control that process, too many parameters. And usually people have only control parameters one by one, a univariate kind of models. Now we have these complex multivariate models that knows how the combination of the temperature, the pressure, the flow rate, the dissolved oxygen, all of it together can actually change the conditions in which the cells grow much better and create the right, let's say, output and create things that are much more valuable. So these are the kind of transformational changes that we are now seeing from a perspective of when you're deploying IoT devices on the ground and trying to basically get some real outputs out of it.